Good afternoon, sir. Jay, sir.
Hello, am I audible, sir?
Yes, sir. Audible, sir. Good afternoon, sir.
Jay, sir, is it audible? Yeah, it's audible, sir.
Thank you, sir. Thank you.
बना के इलेक्शन लड़ रहे थे, उससे टाई अप किया।
Good afternoon, participants. The session will be started shortly. We are waiting for the participants to join. Thank you.
Good afternoon, sir. AICTE-STTP, sir. Shall we start, sir?
Yes, sir. We can start.
Okay, sir. Thank you, sir. Good afternoon, participants. Today we are joined here for AICTE-sponsored 6 days Smart Agriculture Day 3 session. So the today we have a resource person, Mr. Ajay Kotra from NITDR, Chandigarh. Sir is going to take a topic on IoT-based smartphone, wild animals protection, and automatic irrigation. Before we are getting into this session, let me have a small intro about our today's chief guest. Yes, Bhaskar.
Yes, sir. Nothing makes a great day without a magical touch of your love. You rock my world as always. I am saying about the person who is none other than our today's resource person, Mr. Ajay Kotara. Let me see about his biography. He obtained his Bachelor of Engineering in Mechanical Engineering from Technology Education and Research Institute and Bachelor of Technology in Mechanical Engineering from Kurukshetra University, Haryana in 2012. And he completed his Master of Engineering in Manufacturing Engineering from Punjab University and Master's degree in Manufacturing Engineering from National Institute of Technical Teachers Training and Research, Chandigarh at 2016. He has a knowledge in various domains like 3D printing, robotics, computer vision, IoT, machine vision, and etc. And he has both hardware and software programming skills like C, C++, Python, MATLAB, PLC, Arduino, Raspberry Pi, STEM kit, and so on. He possesses totally 5 years of industrial experiences and he is a founder of Innovate Skill Chandigarh. And also he is mentor of change in Atal Innovation Mission and he also in Mission Terry Making Team at Kurukshetra, National Institute of Technical Teacher Training and Research Chandigarh. There is a no limit for his success. Now I request our resource person, Mr. Ajay Kotara, sir, to deliver his speech on the topic of IoT-based smartphone. Please, sir.
Thank you. Thank you so much. So, very good afternoon to all the participants over here in this training program. So, in this session, I'm going to discuss about IoT application in a smart farming. because now in these days might be you are seeing a lot of protest by farmers. So government is also doing a lot of for the farmers. So I will discuss over here that how we can do technology intervention in a farming and how we can build a smart farm over there. So let's get started over here. So first of all, we are going to discuss quickly about IoT and in a smart farming, that how we can implement it over there. And then after that, we are going to discuss about some application of smart farming and how we can build some innovative product for a farmer. So from the scratch, how you can start to build any kind of IoT based product that can be related to particular farming or agriculture, or that can be related to industry also. But in this session, we are going to emphasize about farming application, that how you can integrate IoT in a farming and the smart farming applications. So these are major industrial revolution that happened in the past. Similar way, the latest industrial revolution that is going on in the industry, that is Industry 4.0. So same concept is also implementing in the agriculture domain also, that we can call it like fourth agriculture revolutions. So I mean, what is the relevance of that Industry 4.0 with the smart farming? That Industry 4.0 is based on industry, that how industry can become automatic and can become smart. Similar way, when we talk about farming 4.0, that is related to farming sector or related to agriculture, that how we can make agriculture smart and sustainable also. Because now in these days when we talk about agriculture, there is a lot of society is being carried out by the farmers, and the farmer condition is not good in terms of finance and all that. So how we can empower them? For that we need to do intervention of technology over there, so that whatever they are producing, they can produce it in a low cost, and they can sell it in worldwide wherever they want to sell it. So these are concept of Industry 4.0 that I'm just going to relate it with the farming sector. So these are key principle of Industry 4.0. So when we talk about agriculture domain, over there also we have to implement these things. So when we talk about first one principle, that is how we can make factory digital and smart and flexible. So over there, when we talk about making a factory digital, similar way we have to make farm also smart and digital. So in term of digital or in term of flexible, mean we no need to depend on particular one kind of crop. So we have to do a lot of diversification over there in a crop. That is one challenge for a farmer. And second thing is that we have to make it digital, so that whatever crop the farmer is cultivating over there, that can be monitored, can be I mean proper information can be provided to the farmer, so that whenever any kind of pesticide they have to do, whenever any kind of disease attack over there, that can be monitored. I mean, early monitoring system can also be done over there in a particular farm. Similar way, simulation tool. Now in these days, when we talk about weather forecast, so there are a lot of tools with the help of that we can do forecasting and we can do simulations. So if we want to know that how much crop production level will be over there, that can also be forecasting using simulation tool, that can also be done. Third one is making efficient in farm and regarding energy resources and in term of crop also. So when we talk about productivity of particular farm, that is already in the peak, because we did a lot of revolution in the agriculture domain. We can call it like green revolutions, and already we are on the peak on the production level. But a very important point is that when we talk about farming sector over there, there is lot of wastage. So how we can reduce that wastage, that is very big challenge in a farming sector. And second thing is that how we can optimize their manpower, how we can optimize their resources. So in terms of machinery, in terms of manpower, so that they can get maximum profit in a minimum investment. So that is very much important. So these are a major component of Industry 4.0. All these component, all these buzzwords can also be integrated in a farming sector. When we talk about IoT, that also can be integrated in a farming sector. When we talk about cloud computing, artificial intelligence, sensors, 3D printing, all these things we can integrate in a farming domain, and we can provide some solution that should be ready to use. So when we talk about this technology, farmer will not understand this technology directly, but they will be based on outcome orientation, that what will be the outcome of this technology. So that should be beneficial for them, so that they can do investment over there, and they can get good return out of that. So who is going to do intervention in their traditional system? For that, all the engineering system, all the companies, those are working in industry 4.0, they have to contribute over there, and they have to provide solutions about IoT, about uh, artificial intelligence, about sensors, so that farmer can implement it and can come up with some production by increasing some production, by having some more money in their hand. So these are IoT ecosystem. So there are many applications of IoT. So over here we are going to discuss about one of the major applications that is in the India, that is about in agriculture domain. So this kind of automation is going to happen in upcoming 5 to 10 years, so that you can visualize. Similar way that automation is also is being going to integrate in a farming sector also, and everything is going to become smart over there in a farm. So whenever we have to monitor our farm, that can be monitored over there using a drone, and we can monitor everything over there. That can also be done in upcoming days. So what exactly Internet of Things? So when we talk about IoT application over there, so IoT means a smart system, and the Internet of Things are driven by a combination of sensors and actuator, connectivity, and people and process. That is the general definition of IoT, and simple three major component in a IoT. So that IoT can be implemented in industry and can be implemented in agriculture domain also. So over there, only few things will change. What are the changes over there? When we talk about sensors and actuators, that will be get changed, because in a farming sector, when we talk about irrigations over there, in irrigations, what happened over there? So the sensor required for doing irrigations, controlling their system, that will get changed. So in industry, those sensor will be different, but in a farming domain, that sensor will be different. Only that change will be over there. And second change can be possible over there, that is connectivity. So sometime when we talk about industrial connectivity, that will be something different. And when we talk about agriculture connectivity, over there we have to work out within a different mode of connectivity. So as an example, when we talk about a small factory, and over there we have to connect all the sensor with the internet, so we can use wire also over there, we can use Wi-Fi also over there. But when we talk about farming sector, when we talk about any particular farm, over there it's not possible to connect all the sensor using wire, because the when we talk about area that is higher over there in agriculture. So over there we have to use some foolproof technology for connecting all the sensors without any kind of interruption, without any kind of internet over there. So that kind of technology is required over there. That also we are going to discuss over here. And third one is people and processes. So that will be related to that farming application. Like if we have to build some dashboard on a cloud, if we want to monitor some dedicated things over there in a farm, that can also be monitored using some application or some process over there that is happening on the cloud. So these are sensors and actuators. So these are basic sensors that I'm just discussing over here, but out of that few sensors are directly linked with the agriculture and with the farm. So when we talk about machine vision and optical and ambient light, these sensors are highly important in agriculture domain. So the second one is acceleration and tilt. With the help of that, we can detect any kind of movement over there, any kind of wild animal also we can detect over there. And then third one is electrical and magnetic. With the help of that, you can detect directions. So third one is leak and level. So if you are going to water any particular, mean going to do irrigation over there, and if you want to check level, that also you can check using sensor. So third one is force, load, torque, and strain and pressure. So that is for dedicated pressure application during irrigation purpose. And flow also you can measure for irrigation purpose. And then chemical and gas, if there is any kind of leakage, that can also be detected using gas sensor. And then acoustic sound and vibrations, then humidity and moisture. This one is very much important when we talk about any kind of plant. So we are going to cultivate any kind of plant, so over there we need some certain parameters over there for their growth, like water requirement, moisture requirement, temperature requirement, humidity requirement. So all these parameters can be monitored using these sensors, like temperature sensor, humidity sensor, moisture sensor. So we have to do irrigation over there, and how much water is required to that particular plant, and how much after duration that water is required. That can also be scheduled over there according to their data. Then motion, velocity, displacement, that also we can measure using sensors. So whatever sensor that, whatever application of that sensor I'm discussing over here, all sensors are available in the market. From where you can purchase, I will share with you link. Over there you will purchase this sensor in a minimum cost, and you can use it and you can make your application. The last one is position, presence, and proximity sensor. With the help of that, you can detect any presence over there, any wild animal presence over there in your farm, so that you can detect it and you can repel them. So these are mode of connectivity. So how you are going to connect all these sensors over there in different locations? Like if you are going to monitor one plant, so in one farm there will be approximate 1,000 plant. So how you can monitor all the plant, and with the minimum cost? That is the major challenge over there. So these are mode of connectivity in a IoT. So over here we are going to discuss one of the major mode of connectivity that is being used in a agriculture domain, that we are going to discuss. So first one over here, that is power line, Ethernet, and printed, or like barcode, or this code you will find over there, and you can detect and scan that item. And you can use RFID, antenna, NFC, and these are mode of communication. And one is LoRaWAN, or Zigbee. These are being used for that agriculture applications. So what is the major difference between LoRaWAN and other mode of connectivity like Wi-Fi and Ethernet? So in a LoRaWAN, that is being used for long range. LoRaWAN, long range. WAN stand for wide area network. So that is the full abbreviation of LoRaWAN. So when we talk about LoRa, their mode of communication, that is being possible using that radio frequency. So there is no requirement of any internet. There is no requirement of any mobile network over there. Directly we can communicate with that LoRa with the two end devices using radio frequency. So that is effective technology that is being used in that agriculture application over there. So how much range of that LoRaWAN? That is very important part. So when we talk about LoRaWAN, that range is approximate in average. When we talk about that is 8 to 10 kilometer, and if we want to enhance that range, that can also be possible. And 10 kilometer in a radius. So with the help of that, we can communicate with a long distance, and we can connect more sensors. And second advantage of that LoRaWAN is that we can mean our LoRa and node can sustain up to 2 years without any external power supply. Mean if we are going to put any battery over there, that can sustain up to 2 years. Mean that is very low energy device. So that is the major big advantage of that LoRaWAN, because when we talk about farmer and if we are going to deploy something, so they are not going to do charge every time, and there is no any kind of power source over there. So either we have to use some solar, or and if we are using some solar or something like that, that cannot be sustainable over there. So we have to use some foolproof technology over there, so that they can sustain for a long time. So then you can use Bluetooth also for a short distance, and the Wi-Fi is being used for communication with a small space, or we can say up to 100 meter. We can communicate without internet. So if we have to connect with the internet, for that we have to use, we have to connect via satellite, or we have to connect via 4G cellular network, GPS, or some Wi-Fi connectivity over there. So if that is not possible over there, we can use cellular network for some particular gateway point, and over there we can send data to the cloud. That can also be done. So these are mode of connectivity. So when we talk about agriculture application or smart farming applications, so over there we are going to use that LoRaWAN, that is foolproof technology for that. So these are third part of that IoT. First one was sensor, second one is connectivity, and third one is people and processing. So when we talk about process and people, it means everything is happening on the cloud. I mean, we are acquiring sensor data and we are sending that data to the cloud, and after that we have to perform some application over there. So what kind of application we have to perform? Like if we have to acquire any particular plant data, so over there we can do some forecasting, we can do some analytics over there, and we can build some mobile app. With the help of that we can visualize data. Like, so when we talk about weather forecast satellite, so weather forecast satellite is capturing image and after that sending that image to particular analyzer, and they analyzing it that at what time, what duration, how much percentage of rainfall is over there, that can be analyzed over there. What will be the environment weather over there in upcoming 1 week, so that can also be analyzed and forecasted. So that you can do it, you can do remote monitoring and maintenance, control and automations, supply chain management, security and energy. You can make mobile app also on the cloud. So whatever data is coming, you can analyze using mobile app, and location and tracking, financial. So all these things you can do it on the cloud. So that is cloud activity. So when we talk about the interaction between sensors, connectivity, people, and process, so all these come after combining, they are coming out with some multidisciplinary or some smart application and services. So what are the applications that is being come out using these things? So that I'm going to discuss. So let's go. So like smart sprinkle control, that is for irrigation purpose. So that sprinkle system you can control using mobile app. This one is a cloud application. I mean that user interface. Over there you can monitor all the sprinkle, which one sprinkle you want to turn on, which one you want to turn off. That also you can do it, and you can monitor each and everything over there. So that Lono is a company that is working on that smart sprinkle system. So then after that, hydroponic system. So these are one of the application of smart farming. Sometime in some places over there is a water shortage. So that is happening in major region in the country. So there is no proper groundwater. Sometimes that groundwater is hard, and that is not good for cultivation of a particular crop. So over there, how you have to sustain when there is no proper fertile land, when there is no proper water for irrigation purpose. So over there you can use hydroponic system. That is fully a smart system. And in the hydroponic, what you can do, you can plant that particular crop in a particular environment. So that environment you can control. So that is very important part over there. So this one you can see at the back side, that is a plant that is being cropped in a controlled environment. Over there you can monitor each and everything. And a very important point when we talk about hydroponic system. So in a hydroponic system, you no need to provide any kind of soil over there. So that plant is being planted over there in a, without soil on a water, and water is being circulated on a pipe or in particular vessel in a limited amount, and all the nutrient you are going to supply over there in an automatic manner if your hydroponic system is fully automatic. So it means whatever nutrient is required to that particular plant, that is being supplied automatically, and that you can check it out using mobile app also. When you can control each and everything over there, and if there is any kind of deficiency of any kind of nutrient on that particular plant, so or particular kind of vegetable also over there you can grow, so that you will analyze and you can get a notification on your mobile app that this one nutrient is required. You have to and that nutrient is not available properly, proper availability is not over there in a stock, so you have to fulfill that stock. So that can also be done, and everything is coming on your mobile screen using internet or using Bluetooth. So this plant hydroponic system you can make it at your home also, and you can deploy it at your home, and you can make some greenhouse over there, and over there you can make it. So that is very interesting, and that is Israel technology of doing crop cultivation over there. So these are smart gardening. These kind of thing also you can make it at your home. And when we talk about smart farming, that is not based on only everything you have to implement on the farm. If you are going to grow some organic food, organic vegetable at your home, that also you can do it, and you can make it fully smart. So these are very small models that you can implement, and you can implement IoT over there, because all the resources is over there, electricity is over there, internet is also over there. So you can connect it easily, and you can grow good quality of organic vegetables at your home, and you can fulfill your hobbies of doing gardening and all that. That can also be done. So these are few ready-made solutions few companies are providing based on hydroponic or some kind of we can call it gardening system also. With the help of that, you can grow some kind of particular vegetable over there and flower over there. So these are smart garbage can. So this thing also can be built over there, and that is being powered with the solar. So that for collecting garbage over there. So this one is waste management in a smart city, and similar way. So I'm just going to relate that smart city concept through IoT with the smart farming. So everything is same, nothing difference over there. Just that smart city is just shifted to smart farming. So just see it. So I'm just explaining first of all that smart farming system, smart city system. Then after that, I will share with I will link it with smart farming. So in a city over there, you can see there is different location at different location. There is different dustbin. So all the dustbin are connected with the internet. So what is happening if any one of the dustbin is get filled, and what is happening over there, that dustbin is sending data to the cloud, and from the cloud that data is being sent to the driver, that this one dustbin at this location is already filled, so you have to vacate it. So what is happening, that truck is going at that particular location and going to vacate that dustbin. So that process is happening over there. And this one is fully smart. All the dustbins are located at different location, and distance is too much high, like 2 kilometer far, 3 kilometer, 10 kilometer, that can be 15 kilometer also. And all the dustbin are connected using LoRaWAN, and they are communicating with each other and sending data to the cloud. So that you can do it, because everywhere when we talk about city, there is no internet connectivity. Similar way, when we talk about smart farming over there also, all the different sensors are deployed at long distance, and they are communicating with each other and sending data to cloud. So when we have to send data to the cloud, we have to set up one internet connection over there in one location or one remote control room. From over there, all the data of sensor will go, and from that control room, or we can call it gateway, we are going to send data to the cloud on the internet, and then we can perform some applications. You can see over here in IoT in agriculture. So over here you can see that all the data we are acquiring from that particular farm. So sometimes we are going to do irrigation over there using hydroponics, or using that drip irrigations, or we are going to do irrigation over there using some sprinkle system also. So everything we can monitor and everything we can control it, and all the data is going on the cloud. Like when we talk about any greenhouse, over there also you can see all the data is going on the cloud, like temperature data, like weather data, like outside rain data and moisture data, water level data, everything, all the data is going on the cloud. So when data is going on the cloud, we can do a lot of analytics with the data, and we can perform some application using that analytics, and we can integrate AI over there using IoT. So these are devices that is being used for IoT. So just see, when we talk about sensors, so what kind of sensor we have to use over there in a agriculture applications or smart farming. So the major sensor we are using over there, that is light sensor, motion sensor, and soil moisture sensor, and weather conditions like temperature, humidity, wind, rain, and air pollution like dust and pollutant gases. So these sensor is required for smart farming. And then after that, actuator. When we talk about actuator, what is actuator? Actuator means something output we have to do, means something we have to control. Like there is any tube well, and with the help of that we are doing irrigation in a farm. So what we can do, we can control the tube well motor using actuator. So that is known as actuator. So like any kind of electric switch you have to control, or any light you have to control, or temperature you have to control in a greenhouse, that can also be controlled using actuators. So then you can use some RFID tag also over there for animal identification and monitoring. So that also I'm going to discuss with some application, that how you can make any project to detect a wild animal, and you can make some wild animal protection device, that I will discuss with the practical and using some tools. So then you can use some camera also for monitoring purpose. So RFID tag is being used for animal monitoring, and the drone can be used for monitoring of fully complete farm. And you can use camera also for detection of uh, any kind of like if there is any kind of disease, that can also be detected using camera. So this one is a understanding how wireless connected sensors can help in a plant care. So like this one is plant over there, and these are sensors. Sensor like pH sensor, ppm sensor, moisture sensor, temperature sensor, light sensor. All the sensors are connected. And this one is actuator, mean light we have connected over there. So what is happening? All the sensor data is going on the cloud. First going in a base station. From this base station, all the data is going on the cloud. And from the cloud, if we have to control something from the office, we can control that data over there. So wireless transmitter or receiver we are using over there for a LoRaWAN. So over here you can see this one is a greenhouse, and over there moisture, temperature, water, light, all the data we are acquiring it, and that data we are going to send it on the internet. And from the internet, what is happening? We can monitor all the data on a mobile or office, and via tablet also, and using smartphone also. So all the data we can monitor it. So what more we can do it in, like greenhouse monitoring, we are doing it over here. So we can make alert and notification through internet. So critical equipment control also we can do it. So what is the meaning of alert and notification? So when we talk about alert and notification, mean if there is any kind of disease attack over there in that particular plant. So what we can do, we can send alert and notification via mobile. So we are going to receive notification on mobile app that this one plant is being attacked by some disease. So you have to follow these measures to uh, prevention of that disease. So that can also be done using alert and notification using cloud. So that also I will share with you in a detail. So these are live farm data. So data is very much important when we talk about the application of IoT in agriculture. So with the help of data, we can do a lot of applications. We can do a lot of forecasting. So like monitoring soil moisture and temperature, that we can do it, controlling irrigations and efficient uses of input like water, fertilizer, pesticides. So these are very much important. So as an example that just I'm sharing with you, like in these days there are different kind of crop in different region of the country. When we talk about Haryana and Punjab, over there in these days you will find that wheat crop you will find over there. So when we talk about wheat crop over there, the farmer has to do irrigation in a like canal, or this kind of irrigation they have to do, or either they have to use tube. So they are just doing flood irrigation over there. And the second thing is that when they have to provide the nutrient like fertilizer. So what they are doing, they are just throwing like urea and all that fertilizer like DAP and urea. They are throwing via hand like this, and there is a lot of wastage of those fertilizers. So what can be done over there? When we have to supply water over there, with the help of that water, we can supply proper nutrient using water. So what is happening? Just as an example, I'm just sharing with you that how you can cut cost over there using some technology intervention. Like if we have to in a particular wheat crop over there in one, I'm just talking about 1 acre land. or we can call it, we can use 1 hectare land also. So in 1 hectare land over there, they have to provide approximate 4 bag of urea. So they used to throw that 4 bag, and the cost of 4 bag urea is approximate 1200 rupees. So that can be managed using 4 bag of NPK, something like that, NPK. So those 1 bag cost is 100 rupees. So with 4 bag, you can manage it with 40 rupees. But that NPK, that soluble NPK, that you have to use it using water or using sprayer. So when you are going to supply water over there, that NPK, we can mix it and we can save a lot of cost over there. So these kind of technology intervention or awareness we have to add on to the farmers, so that they can save a lot of money over there, and they can utilize their nutrient and fertilizer and pesticide over there in a proper way, and they can manage water also efficiently. Like this one you can see it. So this one is a flood irrigation over there, you can see it, and this one is a drip irrigation over there. So that detailed picture you can see it over here. So that is manual way that all farmer doing is, and there is a lot of wastage of water. So if we are going to use that drip irrigation system, and there is a lot of subsidy by government also, like 80% approximate subsidy in that vary in different state also. So with the help of that, you can save a lot of water over there, a lot of electricity over there, and a lot of you can get good crop also. Whatever when water is required, so proper amount of water is being get supplied over there. No excess water, no less water. So these are field connected, like if we have to connect all the fields with the internet, so that also can be connected. Different sensor is being deployed over there in a farm. All the sensor data is coming over here, and from this device, we are going to connect it using internet via satellite or via mobile network, wherever we have to connect it. Whatever mode is available in that country, that we are going to use it over there. So these are few companies those are working in these smart farming, smart garden hub. These are sensors. They can control valves for irrigation purpose. So these are companies those are working over there. So those companies are working on different countries like Australia, US. But in India, there is huge requirement of this kind of startup or this kind of companies or this kind of product over there. So, and the very important point, that products should be very much cost effective. Then only they can survive in the India. So over here you can see that how that is being sprinkle is being controlled using mobile. So the mobile app, and that is connected with the Wi-Fi and cellular data, and that is connected with a controller. So which one sprinkle we want to control it, that can be controlled using mobile app, and we can control gardening light also. So a few more application over there using IoT in agriculture, like reduced cost of production, connected greenhouse, and stables, livestock monitoring. And this one is a connected cows. Then you can monitor that cattle also. So when we talk about farming sector, so over there, when we talk about dairy farming, so that is one of the major contributor over there in the economy of that farmer. So how you can monitor that cattle? So when sometime what is happening in a manual way, when we talk about how a farmer are monitoring their cattle, so they are doing it in manual way. If there is any kind of disease attack over there, they cannot. They cannot save their animal sometimes. So recently, one incident happened over there in Haryana. So over there, more than 50 to 60 buffalo get died due to some kind of disease attack over there. So that is very huge amount of loss for that particular farmer. So how that can be avoided? That can be avoided using technology. So we can integrate some sensor over there. We can monitor some parameter of that particular cow, and if there is any kind of disease attack, or that cow health is not well, so that can be trackable, and that can be monitorable, and some preventive action also can be taken over there for avoiding any kind of disease attack. So these are a detailed picture over here, like we can use wireless pH sensor, temperature sensor, and that sensor is communicating over here wirelessly using Bluetooth or Wi-Fi. And this one is collar, and other sensor like temperature sensor we can mount on the ears over here. and this one is a gateway. Gateway is deployed over here with this caller. So the gateway is sending data to the cloud, and you can monitor it locally also on the spot. That also you can monitor it. So these are connected tractors. You can connect all the tractors like this, and you can monitor them. So that is for big farmers. They can use it for they are having a huge amount of land that they can monitor all the farm, and they can make fully farm automatic, like this kind of system. So these are detailed monitoring, like all the parameter of that particular farm. We can monitor it, and we can perform some application using remote control. So these are more application like pest monitoring, storage monitoring, track farm product, prevention of illegal logging, mobile money transfer. So that is using NFC card is being used for transferring mobile payment. And these are some drone application in agriculture domain. So now in this day that is so much popular. So like if you want to spray that particular crop, so that can be done using drone. So there is a lot of intervention of drone in agriculture. So you can see over here few applications like crop monitoring that you can do it, and then after that you can do animal monitoring, and building and equipment monitoring, and that you can do it, and some miscellaneous application like research, smart data, and some analytics also you can do it using drone, like variable rate of fertility that you can detect it using drone, diagnosis of any disease that also can be done, water stress, crop yield that also you can monitor, soil erosion, wild animal damage that also you can monitor it using drone, and spray also you can do it over there. So that spray also can be done. So these are few application of that drone.
Mr. Ajay Kotra, sir. Sir, your mic get muted, sir. Kindly unmute it, sir.
Yeah, sorry for inconvenience. So now these are few application over there that we can use using drone. So now we are coming back to few more application, like this one is a drone. Over there that vision system or camera is being mounted. So if there is any kind of any pest attack over there, that you can monitor it using image processing over there. So if there is any kind of particular pest over there, like this one, you can monitor it, you can diagnose it using AI, and you can decide any kind of proper that the pesticide for that particular pest. So now few more application over there, like big data, all the data you can acquire, and you can monitor it, and you can monitor your tractor, you can monitor all the crops, so you can monitor your cattle. So everything can be monitored. Smart analyze you can do it, planning you can do it, smart control you can do it, smart sensing and monitoring you can do it using IoT. So these are futures farm, smart farm. So when we talk about future, so over there you can see that all the cattle is being monitored with the cloud. This one is representing Wi-Fi. So and all the, like these are drones, they are monitoring over here. These are some different machines. Those are doing cultivation over there. These are smart tractors. So they are doing. They are also connected with the internet and doing some process over there. So everything is connected with the internet, and the farmer is monitoring from home. So everything is monitored and controlled from their home or their office, we can call it, and that is fully controlled. So there is few prerequisites for designing any IoT system. So over there, you can see like a robust model that should be over there. So now over here, like scalability, that is also very much important. When we talk about any smart product, we have to make it scalable also. That is very much important. So there is a lot of affordability is very much important, because in India farmer are not too much rich. Very small farmer is over there, and their financial stability is not good. So we have to make something that can be affordable also. So sustainability is very much important. So if we are going to deploy something, it should sustain up to 1 and 2 year, and more than that, so that that can be sustainable. So some constraint over there for implementation of IoT in Indian agriculture scenarios, like small and dispersed land holding, because everyone is having 2 and 3 acre land. So complexity and scalability and affordability of technology. So that is very much important. Privacy and security concern is also there. Internet connectivity and availability. So that is very less available in the farming sector or rural area. So low awareness of IoT devices. So we can do some awareness also over there. So for that we have to build something that can be deployed over there in particular land or particular farm. So lack of investment also, that is a major issue, like venture capital fund, environmental impact, that is also we have to take care. So influence of human moral decision making. So when we talk about decision making in a particular farmer, so a farmer used to take decision based on their colleague and their neighboring farmer. So what they are doing, and according to that they are taking decision. So strategy to familiarize among the extension personals. So these are few strategies you can implement it. So now I'm coming back to some applications, that how you can make some application and some IoT product. So when we talk about product, so let's come to that product part. So how you can make some product and that can be useful for IoT application in a farming sector. So I will start from the basic, from the Tinkercad. This one is a tool that you can use it for learning applications, that about sensors, about actuators, about programming. So everything you can understand over here in the Tinkercad tool. Might be you are familiar with it. So if you are not familiar, so I'm just telling you from the beginning that how you can use this tool for any kind of circuit simulations or any kind of sensor simulations, and you can make any small application over there. So after that I will link each and everything with the cloud, and I will make some application over there for like weather monitoring or something like that. So some application we are going to build it. So first of all we have to search the Tinkercad on the Google. So I'm just doing Google. So go to Google, and over there you have to search Tinkercad. Tinkercad, that is open source too. So over there you have to open that link, tinkercad.com. So after opening that, you have to go to join now. If you are doing it first time, you have to go to join now option over there, so that you can see it. So now I'm going to click over there. So join now. So over there is 3 options. If you are going to try with me, that also you can do it. If you face any difficulty, then let me know. I will try to solve your difficulties or any error over there. So as you are going over there in a join now options, so over there you will find create a personal account, that you have to click it. No need to click on first two, directly click on third, create a personal account. So after doing that, you have to click on that sign in with the Google. So these are 3-4 steps you have to follow it. After that, it will ask about permission of your Gmail account. If you have already signed in your Chrome browser, so it will directly do login over there. So now I have just logged in with my account, and my account is created. So first of all, we have to go to circuit. So we are going to work on the circuit part. So we have to go to the circuit on the left hand side menu, and over there you will find create new circuit. So if you are doing it first time, you will find something over there, try it now. So leave it that, you can go to create new circuit. So as you are going to click on create new circuit, so what is happening, your dashboard will get open, and over there you can make any kind of circuit. So I will make some circuit that is related to farming sector, that how we can make some smart application for a smart farm. So that I'm going to discuss over here. So first of all, I'm going to let you know the tool, about this tool and how you can use this tool for learning purpose and for teaching kids and teaching student also. That is very much effective tool during this corona period. So now these are component over there in the right hand side. All the component you will find it over here. These are basic component. If you want to go with advanced component, you have to click with all, and you will find all the detailed component. So all the essential component you will find it over there, like inductor, sensors, LEDs. Many component is over there, like some gate, ICs and all that, logic gate and all that. So I'm just coming back to that basic component. Yes. So first of all, this one is my workspace. So what we have to do it, we have to take a component from over here and we have to drop over here. So what we can do, we can drag and drop. So I'm going to drag this LED and dropping it over here like this. So this one is my component. So what I can do, I'm just going to connect with battery with this LED. You can take one battery also. So now you can connect it with, this one is anode is positive in LED, so you can connect it. So how you can take this wire, so you can do using this fit to screen. So after doing fit to screen, you can connect it over here, click over here, click it, left click, you can do it, and after that you can take your mouse cursor wherever you want to connect it. So this one is positive, as I told you, anode. So if you are going to connect it directly, that also you can do it. If one more left click from the mouse you are doing it, you can make join over here, turn over there. Okay. So now if you want to connect this one cathode, so this one you can click it and you can connect it. So these are easy connection, you can make it. So after that you can start simulation. This one is a simulation link over there. So you can click on this menu and your simulation will get started. So what is happening? Your LED get damaged over here. You can see. So why this happening over here? Because I think maximum participant from the electronics background. So if you want to respond it, you can respond on the chat box that why this LED get damaged over here. That is very basic question. So you can answer in the chat box that why my LED is getting damaged over here. So you can respond in the chat box. So why my LEDs are getting damaged over here? Larger voltage. Yes, that is one possible reason, because of excess power. Very good answer over here. That Sandeep has answered that excess power. So that is also one reason over here. So how we can control it? How we can control that power? For that we have to use some resistance over there. So you can take some resistance. So how much value of that resistance is required, that we can calculate using Ohm's law. So that also I will let you know. Yes. So I'm going to connect it like this. So yes, now you have to tell me that how much value of this resistance is required. As I'm going to click on the resistance, you can enter your value of that resistance. Right now it is 1 kilo ohm. So how much value of that resistance is required to glow this LED? I'm just sharing with you few parameter of that LED and that power supply. So LED voltage requirement is 2 volt and the current requirement of this LED is 20 milliampere. So and supply voltage is 9 volt. So according using Ohm's law, you have to calculate resistance value. Yes, you have to respond in the chat box that how much value of resistance is required for this LED. So a rough value I'm just making it over here like approximate 100 ohm. I'm just doing it and I'm going to check it out. Start simulation. Now value, it is showing some warning. So as I'm going to take my mouse cursor on the warning, it is showing that current through the LED is 65 milliampere, while recommended maximum is 20 milliampere. So mean 20 ampere is required, but current is flowing more. We have to, what we have to do, we have to increase that resistance value. So what exact value of resistance is required, that you have to tell over here in the chat box using Ohm's law. So yes, you can respond in the chat box. So that is very basic question that is using your Ohm's law. You have to calculate it. Yes, I'm waiting for your answer. So do it fast. Yes. So when we talk about calculation, so over there we have to use simple Ohm's law, V is equal to IR. and we can calculate that. Is very basic question. I'm not going to discuss in detail. So 3.5K is wrong answer. That is not correct answer. Yes, just do any kind of guess also, that also you can do it. There is no charges for doing any kind of guess. So any guess you can give over here. So any guess answer you can type over here in the chat box. So that mean my motto is over here so that everyone can be active, it can be participative over here. 400 ohm is also wrong answer. 3.5K, that is also wrong. Okay, so I'm going to answer it over here. So that value will be 300 ohm. So let me show you that 300 ohm is correct or not. So what I'm going to do, I'm going to put value over here 290. So let me check it out. It's showing warning again. So now I'm going to make it 300. So 330, I think that will be 330. 320. Again it's showing warning. Yes, so 350 will be the correct answer. 350 ohm, not kilo ohm. That is very important. So 350 ohm. So how you can calculate it? For that I'm just sharing with you that how you can calculate it. Okay, so how you can calculate it? For that you have to use simple Ohm's law. Ohm's law is saying that V is equal to IR. Everyone know about it, I think. So V is equal to IR. So very important point. So what is V? V is equal to V supply, and V supply, that is supply voltage, minus V forward. Forward is a LED requirement voltage. So I is IF. I is IF. IF means forward current for a LED. So IF value over here that I told you, that is 20 milliampere. That is very much important, 20 milliampere. And V supply is over here, that is 9 volt. V supply is 9 volt. And V forward is 2 volts. So these value you have to put it over there, and you will able to calculate the resistance value, that will be 350. So that you can calculate it. So now coming back to that. Yes. So that you can calculate it, and if you are going to increase that value, then also LED will work, but that brightness will get reduced. So everything you can check it out over here in this simulation tool, and your LED and your component will be safe. And after testing it over here, and you can make it in a real project also. So that is very basic thing using this tool. So how you can delete the component over here. This one is the option of undo, redo, and this one is a delete. Any component you can select it and you can delete it. So that you can do it using this. So now we deleted that all the component, and now we can make any other project also. So any other component we can connect it, we can measure RPM also. So one more project. So this one is my motor. So you can connect motor with the battery. So there is different batteries available also over here. So as you are going to search battery, or you can search power supply. So you will find different power supply over here. So like this one is a variable power supply. So over there you can set voltage and current, all these things you can set it. And you can use some sensor also over here. So I'm just using one more sensor over here. So sensor, let me use any kind of LDR sensor. So this one is a light dependent sensor. So how this sensor is working, let me briefly explain you. So this sensor is working based on light. As we are going to fall light on this sensor, what is happening? The resistance of this sensor will get changed. So this one sensor is working as a resistive sensor. So I'm going to connect it in a series with this motor, and this one I'm going to connect it directly. So what is happening at full darkness, the resistance of the sensor will be too much high, and at full brightness resistance will be minimal. So let me check what will be the impact of that resistance over here in the motor RPM. So you can start simulation. So we have supplied the 5 volt, and the output is 3 RPM at full darkness. How you can check that the darkness is full or light brightness is full? You can click on this sensor. So as I'm going to click on this sensor, what is happening? You can see over there full darkness. So you can move it, slide it. And as we are increasing, you can see we are increasing light intensity. So RPM is increasing. At full brightness, you can see RPM is 1000. So if you want to increase voltage, that also you can increase. So let me make it 12 volt. So manually also you can feed it 12 volt. So RPM is 2637. At full darkness, RPM will be 800. So similar way, you can simulate all kind of sensor over here. Those are available so that you can make it. So now I'm going to make one project for detection of wild animal for agriculture applications. So how you can detect wild animal without microcontroller or with microcontroller, both I will share with you that how you can use microcontroller also over here and how you can do programming of that microcontroller in a very easy way. So let me take one more sensor. This one is a PIR sensor. PIR stands for proximity infrared sensor. So that sensor is being used for detection of human being or any kind of animal also can be detected using this. Means any living being can be detected using this sensor. And range of the sensor is also approximate 10 meter to 15 meter. So up to 15 meter, you can detect any animal over there in any field. So when we talk about the usability of this sensor, application of this sensor is being used in many applications like might be you have seen like smart door. Smart door might be you have seen when you are going to in a hospital or restaurant over there. You might be have seen automatic door over there. So what is happening? The sensor is being deployed over there at the top, and you will able to see that this one is PIR sensor. But over there, you will not able to recognize like this because that is being covered in some box or some glass. So how you can use this sensor for some applications? Let's see it. So what I'm going to do, I'm going to connect it, and first of all you can check there is 3 wires. So what is the meaning of that wire? You can take your mouse cursor over there and you can check. This one is a signal wire, then middle one is power wire, and this one is ground. So in a power and ground you have to supply voltage to this sensor. So I'm going to connect voltage over here. So you can take a power supply. 5 volt is required for this sensor. So I'm going to take power supply. So power, you can take it. This one is power supply. So this power supply, I'm going to connect it over there so that you can see it. So after connecting it like this, so this one is positive. So positive. This one we have connected power. Positive with power. Ground we have to connect with the ground. And you can do color coding also over there, like ground we can make it black, and let's see over here, let me make it black, and power you can make it red. That also you can do it for better visualization. This one is the output signal. So signal wire I'm going to connect with the motor or with any kind of let's take it with motor, or you can take some speaker or some light also. So let me make use of speaker over here. So you can find buzzer, video buzzer. So this one I'm going to connect it. So negative you can connect with the ground, make it black, and this one is a positive. Positive you can connect it over here with this signal wire, and you can make it orange. So now as you are going to start simulation, what is happening? Let's see. So I have not written any code over there. I'm just directly making it using sensor and power supply and buzzer. So let's see how you can detect any wild animal over there. So I'm just reducing that size using mouse scroll bar. You will able to reduce that size, and I'm going to click on this sensor. After starting simulations, you have to click on this sensor. So now you can see it. This one is any object. So you can do simulation using this object. So you can see some sound is coming. So is any person or any wild animal coming in front of this sensor, and this one is range of the sensor. So now what is happening? I'm going to do simulation of this So any person is coming in front of this sensor, or any wild animal coming in front of sensor, that hooter will be on, that you can see. So after passing that animal, hooter will be get stopped. So that big hooter can be used over there, so that the wild animal get afraid, and they can run away before entering in your farm. So proper sound is not coming because this one is different type of buzzer, that passive buzzer or active buzzer. There is two type of buzzer. So this one is active buzzer. For that you need some proper frequencies. So I'm just checking it directly. So you can use any LED also over there, or you can use any indicator, or you can use motor also. So this one is connecting this sensor directly using this buzzer and using it. So now we are going to use microcontroller also if we want to do a lot of modification over there, or some delay we want to enter. So we can use microcontroller also. But this one is very cost effective. So complete cost of this project will be 150 rupees. So 180 rupees sensor you will get, 20 rupees buzzer, and 10 to 20 rupees battery you can get it, and you can make it this project in 150 rupees only. So now if you are going to use hooter and something else, or some more powerful device for doing some kind of sound, for that you have to spend more money over there. So now I'm coming to use of microcontroller. So whatever project you are going to make it, you can save it also. So like automatic door opener, or whatever you want to make it. So I'm going to make it wild animal. So that rename you can do it via clicking over there on this sensor. So you can double click over here with the name, and you can rename it, and after that you can click it over here. So this name will get changed. After that, how your project will get saved and how you can access it again. I'm going back to this home. This one is a Tinkercad, and this tool is open source. So when we talk about Tinkercad is open source. You can use it freely, and this one is your latest project. So you can open it and you can tinker it again. And whatever modification you want to do it, that also you can do it. And that project you can share with your student also. You can invite people and you can share with this link. And with the help of that link, other student can also see this project, and they can do modification also over there, and you can export it also in some different file format. So these things you can do it. If you want to take screenshot of this project, that also you can take it. So now coming back to another project using microcontroller. So which microcontroller we can use it over here? So in this session, I'm just giving you a quick overview, because everything explaining it over here is not possible in 2 hours slot. So I will try to make it possible for understanding each and everything from the beginning. So what you can do, you can create a new circuit. So in a new circuit, I'm going to use a microcontroller. So when we talk about microcontroller, so there are different type of microcontroller available in the market. So we are going to use it over here, that is Arduino microcontroller development board. So this one is a Arduino Uno development board. Might be you are familiar with it, because this one is so much popular in these days. Earlier time we were using that 8051 PIC microcontroller, but commonly in these days we are using that Arduino Uno or Arduino development board. So there are different Arduino boards like Arduino Uno, Arduino Mega, Arduino Duo, Arduino Zero, Arduino Amkr. So many a microcontroller board are available with different applications. But for general application, for learning application, this one is one of the common Arduino Uno board is available. So how you can use it? So first of all, I'm just going to share about it, that how you can use this microcontroller and what are the functionality. So let me come to that microcontroller so that you can use it. Yes, so this one is a microcontroller. You can use that microprocessor also, that is Raspberry Pi, and that also quickly we will discuss at the end. And this one is a Arduino Uno. So what are the major difference over there? Because you can use Raspberry Pi for some like advanced application or multitasking applications, and microcontroller you can use it for some dedicated application with low cost. So if you are going to make some product with low cost, for that you can go with the Arduino. And if you have to make some advanced project, like you have to do any kind of vision system, you have to use it. You have to do image processing over there. For that, you can use that Raspberry Pi over there. So let me discuss about Arduino. So in the Arduino Uno board, so these are configuration of Arduino Uno. So first of all, you can see these are digital pins. So over here you can see 0 to 13. All are digital pin. You can use digital sensor with these pins, and you can use digital actuator also. Mean you can take input and you can give output also in a digital format. These are analog pins. So if you have to use any kind of analog sensor, so analog input you can take it. So analog input mean you can acquire any analog sensor data using these pins A0 to A5, total 6 pins. This one is a microcontroller that is being used in the Arduino Uno. That is ATMEL series, that is 8 mega 328P. That is microcontroller name. That is 28 pin microcontroller. So that is being used over here in the Arduino Uno. So you can use this microcontroller independent also. So these are power pins like ground, VCC, 5 volt, 3.3 volt. So 5 volt you can give output to the sensor, 3.3 volt you can give output to the any kind of a sensor that is being operated on 3.3 volt, and this one is external power. So if you want to power this board, you can power it using external power, or you can use 9 volt adapter or 12 volt adapter. So there is one regulator, voltage regulator over here, that is being converting that 9 volt to 5 volt. This board is being operated on a 5 volt. So this one is a USB cable. From that USB you can program it, and you can power it also using this USB cable. So no need to connect this one, you can directly connect USB and you can power it and you can program it also. And this one is a reset button. You can reset your program when you are going to upload any new program, or you have to start your program from the beginning. So this one is detail about this microcontroller. So now I'm going to use this microcontroller, that how you can program it. So let's see over here how you can use it. So what we are going to do now, we are going to program it. So let's see how you can do program. So this one Tinkercad we have already discussed. So these are, software is required for doing programming in this Arduino. Like there is one Arduino software also, that is Arduino IDE. With the help of that, you can program it. So now I'm coming back to Tinkercad, and I'm going to share with you that how you can program it. So let me come back over there. So over here you can see it. This one is Arduino Uno board, and this one is powered using USB, and we can program it using USB. So how you can program it? So for that, I'm just going to click on the code part. So in the coding, you can code it, but before that, I'm going to use some sensor over there or some LEDs. So let me connect one LED or any motor, we can connect it. So let me connect one LED. So that LED, I'm going to connect it on ground pin, cathode is ground, and anode you can connect with any digital pin. So this LED is the indicator of input and output. Like if we have to give any output from any pin, we can check it using LED. So I'm going to connect it with 30 number pin, and I'm going to start simulation. So what is happening, my LED will start blinking over here. So why LED gets start blinking? Because I have not written any code. Reason behind that, when we are going in the code, so over there you will find a by default code. So that by default code is for built-in LED. So in the Arduino over there is one LED that is built in. Built in means that is already available in the Arduino, and that is connected with 30 number pin. So if we are going to connect any external LED on the 30 number pin, that LED also start blinking with the interval of 1 second. 1 second on, 1 second off. So let's see over here. I'm starting again simulation. You can see this LED, both are blinking with the same frequency. So how you can write your code? This one is a graphical coding. Might be you are you are seeing it in first time. So this one is very easy to do coding. So graphical coding, you can delete this block and you can make your new code. So as I'm going to connect this LED with any other pin, like 10 number, 12 number, any digital pin you can take it. So I'm going to connect it with the 9 number pin. So now go to the code. Now we have to write code for this 9 number LED. So how you can write code in a graphical way? So for that you have to go to the output block, and over there you have to select second block, that is for digital output. Drag it and drop it using your mouse, and over there you have to select pin number. These things you can try at your mobile also. You can use iPad also over there, and you can make it easily over there. In mobile you will face little bit difficulty while dragging and dropping and connecting wires. So if you are going to practice it, definitely you will able to use this Tinkercad on your mobile also. There is no dedicated app. You have to use that web browser over there in a Chrome, and you will able to open Tinkercad. So over there, what we have to do it, we have to select pin number. So which one pin we are using it, that is 9 number pin. So let's connect that 9 number pin. So we are connecting it, 9 number pin high, and after that you have to go to control. In a control you will find delay. So delay means wait. So how much time you want to make it on. So over there you have to go to control, and you have to select wait. So wait over there, and after that again go to output. Mean LED will be high for 1 second, and then again go to output, take second block, select that pin number, that is 9 number pin, and you can make it low now. So LED will be high for 1 second, then low, and again go to control, then take delay. So this process will repeat for infinite time. So now what we can do, we can start simulation. So if we want to reduce the time, that also we can do it. So that we are going to do in the second phase. So now you can see it, LED is blinking with the interval of 1 second. So now what I'm going to do it, I'm going to decrease the time so that I can increase my blinking speed. So that is 0.3 second. I'm just taking it. Now you can see LED is blinking with the fast rate that you can see it. So that is very basic code for this. So now we are going to use some more application over there. So let's see it. So first of all, this one is about LED blinking. So now if we have to make some application using this, that how we can make it. And second thing is that how we have to deploy that code in a hardware, because that is graphical coding. So what you can do, you can go to the stop simulations, and go to the blocks, and over there in a block plus text. So over there you can see it. These are code in a graphical, and this one is embedded C code that is being generated automatically. So let's see how you can generate that embedded C code. If you don't know embedded C language, then that also you can learn it over here. So let me delete this block. So over there you can see delay is deleted. So this one I'm going to delete it. This one, this one. So now this one is empty program. So again I'm going to make it code. So take this pin, select pin number 9, and then go to control, wait for 1 second. So your code is generated automatically. So duplicate it. Yes, you have to make graphical code, and embedded C code will generate it automatically. So this code you have to upload it on the Arduino hardware to run it on the hardware in the real time. So that also you can do it. So now coming back to that project, that I will show you that how you can upload it on the hardware also, how you can do it easily over there. So now coming back to that project, that how you can make that project using a PIR sensor over here, that is the wild animal detection and protections in your farm. So now I'm going to use one sensor with this. So sensor you can take it, that is PIR sensor, this one. So how we have to connect it? We have to use signal wire for connecting with the digital pin, and power wire we have to connect with 5 volt supply with the Arduino, and the ground we have to connect it with the ground. And then after that, this one is signal wire you can connect with the digital pin, because the sensor will give output that is digital. So you can connect with any digital pin. So I'm going to take it on 6 number pin or 7 number pin, any pin you can take it. So now what we have to do it, we can change color code also. You can make it orange. This one is red, power red, you can make it. This one is green, you can make it black, ground. So all these connection we did it. Now we have to write code for reading that sensor value. So whatever digital sensor we are going to read it, so how we can read it, for that we have to write code. So let's see how you can do coding. So I'm just coming to blocks only. Yes. So by default, this code is earlier code. You can delete this code. How you can delete it? Drag it and put it on the dustbin at the right bottom corner. So I'm going to delete it. So now what we have to do it, we are going to read that sensor. I mean, we are reading some value. We are taking input of that sensor value over here in the Arduino. So we have to go to input, input. Over there you will find these input blocks. So which kind of sensor we are reading it? That sensor is digital sensor. So we have to read that value of digital sensor, read digital pin. Take it, and after that what we have to do it, we have to select that pin number. So pin number over here, that is which one pin we are using it, 7 number pin. So we are reading sensor value on 7 number pin. So now what we have to do after that, after reading that value from the 7 number pin, we have to print it. So mean we have to print on the serial monitor. This one is a serial monitor over here. So how we can print on the serial monitor? Mean we have to give output on the serial monitor. So go to the output block, this one, and over there you will find serial print at the bottom when you are going to scroll down. Serial print, take it and drop it over here. So as you are going to start simulation, so what is happening at the serial monitor, you can see it is printing hello world only, because we have not inserted this sensor value over here. So by default it is printing hello world. So now we want to print that sensor value. So what we can do, this block you can drag it and put it on the hello world. So this block is being get inserted over there. So now we can start simulation. So now whatever value we are reading it, that sensor value we are reading it on the serial monitor and printing it over there. So how you can simulate this sensor? So I'm just going to reduce that size. Yes, this one is sensor. I'm clicking on the sensor and removing that object. Yes, so when any person is coming in front of this sensor, output will be 1, mean high. Otherwise output will be 0. Again I'm just moving it. You can see output is high and output is 1, otherwise 0. So that you can do it. If you want to put some delay, that also you can put it, but I'm not using delay right now, that I will use later on. So according to the sensor condition, we have to turn on buzzer over there. So in the output, so how we can give output in the Arduino, we are going to connect one buzzer over here in the Arduino. So take this buzzer and connect that buzzer with the Arduino. So let's see how we can connect it. So I'm going to connect this positive with any digital pin. You can take it. Let's take 10 number pin. And this negative I'm going to connect with the ground. So now I have connected my buzzer over here in the 10 number digital pin. And now we have to use some condition over there. If sensor value will be high, then only this buzzer should be on. So let's how you can make some conditions. So you have to go to control. In a control, you will find all the condition over there, like if condition, else condition, everything you will find over there. So take it over here, like if and then else condition. So over here, what you can do, you can click over here, like this one is my condition value, sensor value. So I'm going to duplicate it. So right click over here and you can duplicate it. This value you can insert it, because you can put if condition on the sensor value. If sensor value will be high, then only your buzzer should be on. But this one is not getting fit over here. So go to math and you can find that second block and you can insert it over here. This block is being got inserted. Now you can insert this block over here in replacement of 1. Okay, if sensor value is equal to 1, you can change these values is equal to. If sensor value, we are reading it on the 7 number pin, that is equal to 1. So this condition will get satisfied. So if condition will get satisfied, then what you can do, you can turn on that buzzer. So we have to give output to buzzer. So play speaker. That speaker is buzzer. So I'm going to take it over here, and you can select pin number. So pin number is 10 for that speaker, and this one is tone, by default tone, that you can change it also. I will let you know in detail. So in else condition, what you want, that speaker should be turned off. Select pin number, that is 10 number pin. So now after that, what we have to do, we have to start simulation. So I'm going to start simulation. So that simulation is being get started. So what is happening? First of all, you can check on the serial monitor, value is 0. Now you can simulate your sensor. So let me show you. Yes, this one is my object. So there is no person in front of that sensor. If any person or any wild animal is coming in front of this sensor, in the range of this sensor, what is happening? That buzzer will be get on. Now I think you are able to hear that buzzer sound in a well manner. So again, any person is coming in front of that. So that buzzer you can replace with hooter also, or whatever notification you want to send, or whatever alert you want to generate. With the help of that buzzer, you can create some specific sound, or you can use some hooter or something like that. And this one is also this project, same functionality, everything same. That you can use it for COVID-19 also, like making automatic doorbell at your home. So you can make your doorbell automatic at your home, and you can mount the sensor, and you can use this buzzer over there for getting your doorbell on. When any person is coming in front of your door, that buzzer will be get on. So if you want to get different tone in this buzzer, that also you can get it. So how you can get it? You can duplicate this block. So let me use some delay over there. Control, wait, put some delay in if condition and duplicate it. Yes. So this one is frequency 60. I'm just changing it to 55 over here. So two tone I'm getting it over here. So two frequency, one is 60 and second is 55. And I'm going to start simulation. So now over here, as I'm simulation starting. So what is happening? Output value is 0, and as I'm going to any person in any object or any wild animal coming in front of this, so two tone you are getting. It's looking like ambulance sound, but you can make different tone or different frequency over here by multiplying these blocks over there, and you can change that frequency. And you can get you can play any kind of music also using this. So some kind of specific music tone, that also you can play it using these values over there. So that you can do it. So this one is very interesting project, so that you can make it and you can do that coding easily. And if you want to deploy that code in the hardware, what you can do, you can click on block plus text, and your code will generate it automatically. So this code you can copy it and you can deploy it on the hardware, so that you can do it easily. So now I'm just going to deploy a very simple code of LED blinking on the hardware. I will show you that how you can deploy it on the hardware. But before that, few more interesting project I will share with you on the Tinkercad, that you will enjoy it. So let me go back to the Tinkercad. So over there, a few interesting project that I'm sharing with you. Like you can make a piano also over there. That is very interesting project. So let me open it. So this one is a piano project. So over there, what you can do, you can make a piano also over there, and you can play that piano, because sometimes some students are having a different interest. So if they are having the interest in a music, they can also get engaged in their engineering activities, in electronics or electrical or IoT activities. So you can start simulation, and that code also you can make it in a graphical way. So now I'm going to these are buttons like Sargam. You can play it over here, like Sa Re Ga Ma Pa Dha Ni Sa. So I'm not having a good understanding with the music, so I'm not an expert in that, but I will let you know how you can play that tone Sargam. And after that, you can play any song also if you are having understanding with the music. So let's play it. Sa re, ga, ma, pa, tha, ni, ni. So these are different tones. You can play it over there. So any music if you want to play that you can play it, that is up to you. So that interesting thing you can make it over there in the Tinkercad. So now coming back to that project, that how you can deploy it on the hardware. So how you can deploy it. So when we have to deploy any code in the Arduino hardware, so what we have to do over there. So first of all, I'm going to make a very simple project over there, and let's see it. LED blinking, simple project so that we can deploy it on the hardware also. If we are going to deploy that PIR sensor project, for that we need a buzzer also, and we need a that PIR sensor also. So let's see how we can make it. I'm having that sensor, but I'm not showing it right now, so that because if you have to try it, you can make it in a simple way. First, let me take Arduino, and I'm going to connect LED. So you can connect LED on any pin. So I'm going to connect it on ground and 13 number pin or 14 number pin. So let me connect it on the 11 number pin. And this one is by default code. You can delete it. Go to output, second block, select pin number 11. Pin is high. Control wait. Then you can duplicate it for doing it fast. Make it low. So LED will be high for 1 second and low for 1 second. So now go to blocks plus text. This one is your embedded C code. This code you can copy it. This code you can copy it, and you can paste it over there in your Arduino software. So there is two mode of Arduino software. One is on the cloud and second is on the downloadable version or offline version. So I'm having offline version also, and I will show you the cloud version also. So that is also open source. So if you don't want to download, then you can use it on the cloud version also. So over here, what we have to do is we have to search that arduino.cc. Arduino.cc, that website, you have to search it over there. So in the arduino.cc website, over there you have to sign in over there, and there is option over there, menus, and over there is Arduino web editor. So this one is Arduino website, arduino.cc. So over there you will able to open that Arduino website. So it is asking about sign in over there. So I'm going to sign in. So you have to create account over there, and after creating account you will able to do sign in over there easily. So that is also open source, and openly and freely you can use it. So it is in the password. So after doing sign in over there, you will able to make code over there, and this one, all the code is being get saved on the cloud also. So let me show you that how you can make it. So this one is your workspace. Over there you can write your code or you can paste your code. So over there you can verify your code, upload your code directly from this cloud on the hardware. So that I'm going to show you that how you can upload it. So first of all, let me delete it, and let me paste my code over here, whatever code I have copied from the Tinkercad. So again, I'm going to copy it. This one is my code. You can select it and you can copy it. And after that, in the Arduino web editor, you can paste it using Control V shortcut command. So this one is my code. So how you can deploy this code in a hardware? So that is very interesting. So that I'm just going to share with you. So let me show you that how you can deploy that code in a hardware. So first of all, I will share with you that Arduino hardware, that how it will look like. So let me share with you camera. Okay. Yes, over here you can see it. So I think you are able to see that camera. So over there you can see this one is my Arduino Uno. So Arduino Uno. Over there, I have used one external LED on pin number 11 as we have programmed. So that is on the pin number 10. Let me connect it on the 11 number pin. Yes. So I have connected one LED on 11 number pin in my Arduino hardware. So this one is USB cable. That USB cable I'm going to connect it. This USB cable I'm going to connect it with my computer. So let me show you that how it is performing over there. So yes, some participant has asked over here that can we use inbuilt sound only, or we can use our own sound. So you have to use some standard tone. So that frequency you can change it, and different sound you can create it out of that, but you cannot record your sound over there. So now I'm going to connect this USB with my computer. So what will be the outcome over here? In the software, you can say it Arduino Uno. So there is no port is connected. So as I will connect it with my computer, that my USB cable, so you will able to see that COM port will come over here. Yes, COM23. So this one is COM port over there. So now what you can do, you can upload your code directly. So first you can verify your code, and you can see status of your code at the bottom, success, and you can upload it. So now I'm going to upload your code. So after uploading code in the hardware, you can see your LED will start blinking. Upload is done. You can see over here at the bottom, success done. So now your LED is blinking with the interval of 1 second, that is 100 milliseconds. So as I'm going to increase that blinking time, so I'm just reducing that time, and you can upload it again. So my blinking speed will get increased. This one I'm doing on the cloud. So that you can, yes, now you can see LED is blinking with a fast rate. If you are able to see it, success uploading, yes. So real time code you can upload it on the hardware. So whatever code you are making on the Tinkercad, that code you have to copy it and you have to paste it in the Arduino software, and you can upload it on the Arduino hardware in a real time, so that you can do it easily. So now I'm going to share with you some more cloud application. If you are going to make some application of IoT use on some smart farming or some other applications, so how you can make it. So let me share with you cloud. So this one, first of all, I'm going to share with you cloud. So let's see which cloud you can use it over there. So the cloud, we can use it over here, that is Sane Cloud. So that cloud, we can use it over here, that is Sane Cloud. So that is open source cloud. Whatever resources, whatever tools I'm sharing with you, everything is open source. No need to pay anything for that. So you have to do sign in over there. So after doing sign in over there in that cloud, or you can do sign up first time, and after doing sign up, you have to set up your hardware, and like you can set up your Arduino, or you can set up your Raspberry Pi over there. So you can make some applications. So few case studies that I'm just sharing with you. So this one is a smart energy meter. So if your farm is having a tube well, and the tube well is based on electricity, so if you're having a tube well connection, so you can monitor your power supply, power consumption over there at your home. So that you can monitor it using smart energy meter, and that is based on LoRaWAN. So if you want to turn on your tube well and turn off your tube well, that also you can do it using your mobile app, and you can monitor all your parameter, power requirement, and everything over there. So one of the major thing that is important, major intervention of IoT in a tube well, that in a tube well, farmer are using submersible motor. So sometime what is happening, their submersible motor used to get damaged. So why that is happening? Because they are not able to monitor their parameters. Sometime that is running overload or something like that, or sometime due to heat that can burn out. So if that farmer is going to monitor their power, temperature, everything, and how much electricity is being consumed, so that can be monitored. And if there is any kind of temperature is higher, you are going to receive alert and notification on your mobile. That also you are going to receive it, so that you can control. I mean, you can turn off your pump, so that you can save your submersible motor. That can also be done. So these things you can monitor it. Okay, some participant is asking about that implementation of that sound effect with the help of that animal can go back from the farm field. So I will share with you detail, and if you face any difficulty while making that project, I will help you out. No need to worry about it. So over here, this one is one case study, and you can see location also that where is your pump is being installed over there, and that energy meter is being get deployed over there. So you can monitor that pump motor data. And one more project that is based on LoRaWAN, mean your pump is located at 10 kilometer away from your home. So you can monitor it without any internet, without any wireless connection over there. That can be monitored using LoRaWAN. Now, after that, one more application that I'm just sharing over here, that is weather monitoring station. Like if you want to monitor weather data of your plant, that also you can monitor. In your farm, if you want to monitor weather, so how much humidity is over there, temperature, air quality, or if you want to monitor greenhouse parameters, so all the data you can monitor it on the cloud, and you can perform some application also. Like if the temperature is not proper as per requirement of that particular crop in a greenhouse, you will receive notification and alert. So with the help of that notification and alert, you can control the temperature also using your mobile. So if you are at remote area, from there also you can control temperature of your greenhouse. So everything can be monitored and can be controlled over there. So that is the advantage of IoT, and you can see that location also, that where is that weather monitoring station over there, that also you can see it in a very simple way. And this one also you can deploy on the drone, because we have used this weather monitoring station on a drone, and with the help of that drone we can move that drone in different farm locations, and we can monitor moisture and everything. We can monitor it using drone also. That also can be done over there. So that is another project. So these two projects are directly linked with the farming. So there is many more case studies over here that I'm not going to share with you right now, because that is related to industrial applications. So if you want to make it, that you can make it in a very simple way over there. So now few more case studies I'm just sharing over there. Yes. So how you can set up that cloud and all that. So first of all, you have to click on add new, like device and widget, as you are going to click it. So over there, you can connect all the sensors and like microcontroller and microprocessor like Arduino, Raspberry Pi, everything you can connect it over there. Like if you want to make a setup using Arduino, that also you can make it. For that, you have to connect Wi-Fi module over there. That Wi-Fi module you can connect it, and after that you can use it. So how you can set up it, how you can connect it, for that I'm just sharing with you video link, and with the help of that you can watch it later on also, and you can get all the detail insight about setup of that device over there on the cloud. So I'm sharing with you my YouTube link. Over there you will find a detailed video about sensor interfacing over there. So this one is my channel. That link I'm just sharing with you. You can subscribe it also for getting latest update. So these are condition monitoring of a machine or setup of cloud using Arduino plus Wi-Fi module. In this video you will find all the detail, and there is many more videos over there. You will be able to watch it, and you can subscribe this channel, and also you can press on that bell icon, so that whenever we are going to do live broadcast, you can receive notification also over there. So that link I'm just sharing with you on the chat box. So if anyone want to watch that detailed video and want to have interest in Tinkercad and making any IoT based project for smart farming or for industry also, they can watch all the detailed videos, and they will get a lot of information over there for learning free of cost. So that you can do it. So over there again I'm just repeating briefly that how you can set up it. First of all, you have to click on the Arduino if you are using Arduino board, and after clicking it, you have to set up your Arduino. You have to install Arduino software if you have already installed. No need to do it, or if you want to use it on the cloud, then also no need to install it again. Then next, then you have to select your Wi-Fi connection with the Arduino. So we are using Arduino Uno, click it, and then we have to select Arduino Uno Wi-Fi module. This one is one of the cheapest Wi-Fi module you can connect with the Arduino Uno. So after that, your code will generate it automatically. No need to write your complete code. Only few modification you have to do in this code. So this code you can copy it and you can paste this code in the Arduino software. So I'm just copying it and you can paste this code in the Arduino software over there. So as you are going to paste this code, few modifications you have to do it on the code, like you have to set up your Wi-Fi password or Wi-Fi name. So mean you are going to set up your IoT cloud. You are sending data to the cloud in this cloud. So how you can send data over there? You have to connect your mobile, sorry, you have to connect your Arduino with the internet. For that you have to use Wi-Fi module, and that Wi-Fi module you have to connect with the internet. So the available Wi-Fi is required for that. So you can create your mobile hotspot, or if there is any available Wi-Fi network, that Wi-Fi network name and their password you have to share over there. So now as we are going to click it, your code will generate it, and that code I have pasted it over there. So over here you have to enter your hotspot or your available Wi-Fi network name and their password. So this one is essential, and after that few more modification you have to do it over here in a, like what data you want to send on the cloud, which sensor data you want to send. For that you have to set up in this function, like which channel number data or which pin in the Arduino you are receiving data and you are sending data to the cloud. So that you have to select it, few modification you have to do it. That detail you will find in the YouTube video over there in this video, so that you can watch it over there. So after doing all the setup, you have to upload that code in the Arduino. So this code you have to upload it in the Arduino, and you have to connect Wi-Fi module. And after that, as you are going to see waiting over here, that waiting will goes to your dashboard. This kind of dashboard you will find it, like if you are going to send data in 3 sensors, so the data you can monitor it like potentiometer data, that you can rename it. Lot of modification you can do it over there in a very simple way, like light intensity. So everything you can monitor it, and you can control it also like this. So light intensity if you want to control, motor speed you want to control, room light you want to turn on and off, that also you can do it. Similar way that you can make it for greenhouse also, or for smart farm also. So all things you can monitor it and you can control it. So if you want to connect Raspberry Pi, that also you can connect it over here, and you can monitor all the Raspberry Pi parameters and their GPIO pins, mean that input output pin of the Raspberry Pi. That also you can control it. So if you want to know more detail about the Raspberry Pi, for that you will find more videos over here with the Raspberry Pi also. That how you can set up cloud using Raspberry Pi. That also you will find over there in the video. So kindly subscribe that channel so that you can get notification and alert over there also. So that will be very much beneficial for you if you want to learn from the basic, from the beginning, from the zero, so that you can learn over here in this YouTube channel. So now I'm coming back to question answer. So if you are having any kind of doubt, any kind of queries, any kind of questions that you can ask over here in the chat box, or you can unmute your mic and you can ask directly. I will try to answer your questions as per my in my knowledge. So kindly ask your question in the chat box. So yeah, one more thing, if you want to contact me, so just I'm sharing with you my contact details. So you can contact me over here. So these are my contact details. So you can contact me on this number. This one is my WhatsApp number. I'm available on 24/7 on the WhatsApp, and I will try to respond as soon as possible as I will get free time. And you will find me on the Twitter, Facebook, Instagram, and this one is my mail ID. So if you're having any kind of queries later on also while making project, because sometimes right now you are not able to do practice, and when you are going to start doing practice, then you are going to face a lot of difficulty while making that project. So what you can do at that time also, You can ping me that, sir, I'm facing that kind of issue. So help me out. I will definitely help you over there. So these are my contact details. So yes. So now I'm coming back to question answer. So this one also I'm going to type in the chat box also. If you are facing to write it over here. Yes. So these are my contact details that I have shared over here. So also I shared my email ID. Yeah. Yes, if we want to do any kind of, yeah, I'm just taking question answer over here. If you want to do any small automation activity for a small scale farmer, yes, that also we can do it. There is no limitation that we have to make big automation over there. Like small thing you can do it. Like as an example, I shared with you like tubewell. If you want to monitor your submersible motor data, that also you can monitor it, and farmer will receive notification only and only when they are going to, when your motor is on the critical stage. I'm just going to monitor that submersible motor conditions. If that submersible motor bush is down, you are going to receive notification on your mobile via SMS that yes, your bush of that motor is down, kindly shut it down and repair it. If their pump is down, that also you will get notified using artificial intelligence logic over there on the cloud. So these kind of small project you can make it for the farmers, and those are very much helpful. So this one is a recent idea. I just, I'm also belongs to farming sector, and recently I was working with some submersible motors with the tubells. So over there is a lot of difficulty farmer is facing, because sometimes their motor is, their pump is down, sometimes their motor bush is down. So they have to remove it again and again from the well, and it's very hectic process, very tough job. So that job can be become easy by making a small project for monitoring health of that submersible motor or any kind of pump that is being used in a farm. So thank you so much. Hope you enjoyed this session, and if you like this session, kindly subscribe that YouTube channel. Thank you so much, Kumar. So if any participant having any kind of queries, they can ask over here.
Dear participants, if you have any doubts, kindly ask with our resource person.
So Bala Subramaniam is designing some project for smart farming. So how to implement it? So as I said with you, my contact detail, you can WhatsApp me and tell me brief about the projects, and I will try my best possible that how you can make it in an easy and cost effective way. That also I will let you know. Yes, one more link that I'm just sharing with you, that how you can purchase any component online in a low cost. So you can find few website over there like electronics.com. Meanwhile, you can type your queries over there in the chat box. So over there in this website, you will find in very cheap components online, electronics.com. Like when we talk about Arduino, in all Amazon and all that, you will find Arduino in 400, more than 400 rupees. So over here, you will find in 360 rupees, like Arduino, So this one is Arduino Uno, 330 rupees only. You can get Arduino Uno. So yes, yes, yeah. Sensor is Indian made. Now in these days, you maximum, and I can't say maximum, 50% sensor you will find made in India, because earlier maximum sensor used to get imported from the China, but now in these days, those are available in the India, because Chinese import is already get banned. So
Okay. Hi, Ajay sir. Thanks a lot for such a nice session. Okay, so I have a question. So Since I also, belong to farming and, background, but I just wanted to know, let's say if you have a sensors all over the field, so are there sensor available which are kind of, Wi-Fi enabled, or do you need to have a kind of, the wires connected all over and then you need to take it to a controller's module, or how is that?
Yes, very good questions. So when we talk about in the field, we have to connect multiple sensors. So what you can do, you can make a wireless sensor network over there. So wirelessly you have to connect them. Either you can connect via Wi-Fi or you can use LoRaWAN over there. So in a LoRaWAN, as I told you, when there are multiple sensor and they are deployed in a long distance like 100 meter, 200 meter, 500 meter, 1 kilometer. So all the sensor you can connect it using LoRaWAN, and you can acquire all the sensor data in one gateway. That gateway should be connected with the internet. That can be using any CDMA or any kind of GPRS network, and you can send data to the cloud from that particular farm. So that can be done. So for that, LoRaWAN mean that is similar to that Wi-Fi. So that is being all the data is being communicated using radio frequency based. So that AND node, when we talk about sensor, so that is known as AND node in a LoRaWAN. AND node, you can connect multiple AND node, and over there you can deploy a sensor, whatever data you want to acquire it. So that is for long distance communication. Otherwise, if there is small farm, over there you can use Wi-Fi communication also, and you can make wireless sensor network, and all the sensors will communicate with each other, and they can build a sensor network, and with the help of that also, without internet, you can communicate it.
Okay, sir. Okay, thank you. So I'll get connected with you offline.
Yeah, definitely. So,
Sir, there is no more question from participant side, sir. Let me conclude the session, sir.
yes, you can go ahead.
Yes, sir. No person was ever honored for what he received. Honor has been the reward for what he gave. In this way, I would like to thank our honorable today's resource person, Mr. Ajay Gotara, entrepreneur, founder, and CEO at Innovate School, mentor of Change, National Institute of Technical Teachers Training and Research, Chandigarh, for providing the wonderful technical session on the topic of IoT-based smart farm, wild animal protection, and automatic irrigation. On behalf of management and the Department of ECE, once again, thank you so much, sir, for providing this wonderful session. Dear participants, the day 3 session to attendance and feedback link is posted in chat box. Kindly fill it soon. It will be open up to 30 minutes only.